All right, good afternoon, everybody. Welcome to the second of the fall 2020 BCT lectures. So today we are privileged to have as our presenter, Mr. Robert Perschel, Executive Director of New England Forestry Foundation. In his 40 years as an environmental professional, Mr. Perschel has worked on forestry, large landscape conservation, and wilderness issues. A few of his many accomplishments: he is an original co-founder of the Forest Stewards Guild. He's director of the Wilderness Society's network of wildlands and land ethic programs. He's also the regional director for the Northern Forest Alliance and the Eastern Forest Partnership. He's co-author of Climate Change, Carbon, and the Forests of the Northeast. Recently, Mr. Perschel has guided the New England Forestry Foundation's Forest to Cities and Build It with Wood campaign, which seeks to encourage exemplary forestry standards and increase the amount of wood used in construction, a subject particularly relevant to us here in BCT and in our design building. So please give a virtual welcome to Mr. Perschel for this evening's lecture. All right, Bob, that's all yours.
Oh, great. Hi, everybody. This is the first time I've been on Zoom with so many people. It's usually about 5 or 6 people. And usually when I present, I'm asked to wrap it up in 20 minutes and do it fast because there are other people coming after me. So I really appreciate the time that you've given me here. It's a subject I'm really involved in. I think you're going to find it very interesting, if not fascinating, as I get into this a little bit. Thank you for the introduction, Carl. I consider myself a forester, somebody who knows how to go into the woods and manage trees. Although I've done a lot of other things in my career, what really attracted me to get into this business is when I was in school studying, like you are, my professors took me out and introduced me to a biological system, New England forest, and explained how they could be managed and kept ecologically alive and valuable, but we could actually manage them and produce products that human beings need. And that's what really caught my eye, because I figured that's what the world needed. It needed some way to be sustainable. But my career spanned, working in the woods for many hours every day, looking at trees, selecting which ones to harvest, setting up the harvest, feeding mills, insatiable mills in New England that needed timber coming in every day. I did that, but I also worked, as Carl just said, for the Wilderness Society for many years, was involved in wilderness campaigns across the country. So my love spans both managing forests and also protecting them, leaving them alone, leaving no trace in areas. So I'm a supporter of both of those pushes. Sometimes advocates for either forestry or wilderness don't find their way together and they dispute things. I am somebody that always tries to bring them back together to think about how we can make a better world. As a younger man working in the woods every day for 5 or 6 or 7 hours, I really liked it. I love being out on days like this. If you're all in New England, I'm in Littleton, Mass now. What a beautiful day. I can remember being out in the woods on days like this, and it's the best thing in the world. But I figured I wasn't going to do it for my whole career for 40 years. So I didn't know where I'd wind up at the end of my career. But a funny thing happened on the way here is climate change. And I began to realize that I had some particular skills and experience that suddenly were really valuable to the world. And I began to get more and more engaged in this. And that's been my career for the last 10 or 15 years, trying to figure out how to use the knowledge that I and other foresters have to address climate change. And we think in New England, we have a real significant way to do that if we can connect to what you're interested in, which is buildings. We can connect how we manage our forests to how we build buildings. We can do something really important for climate change. So just to consider on the building side, 11% of all emissions in the world are from the construction of buildings. That's a lot. That's significant. So if we make a dent in that, something big happens. I'm reading that 2.3 billion more people are going to be on this planet within the next 30 years, that critical time of climate change. It's a lot of people needing a lot of places to live and a lot of places to work. And how are we going to do that? We can't just ignore that problem coming at us. We have to solve it. And if we build with steel and concrete, it's not going to work. So sometimes you'll hear now, we can't solve the climate problem if we continue to burn coal. Everybody's been hearing that. We have to move away from coal, and we're doing it. Same thing here. We can't solve the climate problem if we continue to build with steel and concrete. It's just not going to work. What can you do as an alternative? And wood becomes one of the possibilities. I hear there's 185,000 housing units that are needed right now in Boston. And most of the demand for units in the Boston area need to be fulfilled in the next 10 years, right up front. So we've got a problem right now in front of us, and something needs to be done. My objective for our time together today is to kind of introduce you to the field of forestry and get you thinking about how you can connect to that field with the building sector. Maybe bring you on as advocates for what we call our Build It with Wood and Forest to Cities program. Most of my talk will be about forestry. I will cover buildings, but I'm not an expert there. You're the budding experts in that field, and you probably know more about it than I and more about the details. I've learned quite a bit, but I'm not an expert, but I understand how it can be connected. So I will talk about buildings, but I'm going to focus mostly on the forestry side of it. All right, so let's get moving here. So this is a quote I just pulled out of a recent issue of Bloomberg magazine, and it brings us right up to date with the climate problem. And what it's saying is that the window for cutting our emissions is just about up. In order to keep our temperature where we need to do it, it's not just enough to stop emitting. We also need to find a way to take carbon out of the atmosphere. And that's where forests come in. So I wanted to note that this is people are just beginning to understand this, that we're so far in the problem that we need to pay attention to forests. So we're beginning to do that. So I want to help you start thinking about the issue. And the best way that people have said to do that is to think about it like a bathtub. So what we have here is a tub with a faucet pouring greenhouse gas emissions into it. And those greenhouse gases, that's what is in the atmosphere. And those of us that talk about this, the words we use is, what does the atmosphere see? In other words, what is the effect of what you're doing on the greenhouse gas in the atmosphere? How does that change, right? So we're emitting greenhouse gases into the atmosphere, but there's also some removals that are going on. The planet absorbs carbon on its own. Oceans absorb carbon. Actually, rocks and minerals absorb some carbon. Not that much, but some. And certainly trees, when they grow, they're sucking carbon out of the atmosphere. So if we want to limit the amount of carbon in the atmosphere, we need to pay attention to what we're putting in and what's coming out of it. Scientists are saying that level that you see in the tub, it's getting too high. If it gets to 2 degrees or 1.5 degrees, somewhere in there, we start to have problems. It starts to flop over the end. Things start to happen that we don't want to happen. So we're trying to keep the amount of carbon in that bathtub down. That's the simple version. In reality, when you look at it, there's numerous tubs of carbon that we have to keep track of, and they're all interrelated with each other. If you think about one of these tubs is the amount of emissions from cars. All right, we'll drive electrical vehicles. When you hop in your electric car and drive around, there's no emissions at all. But how did you build that electric vehicle? That took emissions to build it. And it took rare minerals. And where did those rare minerals come from? They may have come from a mountain in Africa where all the trees were cut off in order to get to the rare mineral. So each tub has a connection to the other tub. So it's like you have a pipe between the two tubs. You do something in one tub, sometimes the water, the carbon kind of flows over to the other accounting tub. And it gets complex. That's why I stuck all these orange arrows all over the place. Everybody's trying to figure this all out. The point being, you can't do any one thing probably without impacting somewhere else. So if you concentrate just on the heating and cooling of a building and the amount of emissions, you haven't adjusted for how much carbon did you put into it to actually create the building. You need to think about that as well. And that's one of the things that we're trying to pay attention to. Everything has its consequences. But let's narrow this down a little bit in my presentation today, and let's think about the connection between forest and buildings, and forestry and what's happening there. And kind of let's think about this in two tubs, if you will. And these are connected to other ones. But if we continue to build buildings out of concrete and steel, we make the steel and have to heat it to tremendous temperatures, we put a lot of emissions in the atmosphere. So that faucet is wide open on the tub on the left. Move over to the tub on the right, and if you think about that as your forest base, as the trees grow, the net removal is coming out of the atmosphere down at the bottom of the tub. So that's a good thing. But if you cut the trees down and put them in the building to replace steel and concrete, you've moved the carbon from the tree into the building. And you could say it's still out of the atmosphere. However, we know when you go into the woods to harvest timber, not every portion of the tree comes out and goes into a building. So we have to account for what's left there. It also takes us fossil fuel to run our logging skidders and transport the wood to the building site. We have to account for that as well. Plus, when the tree is harvested, we hope that a new tree takes its place and starts to grow and sequester more carbon. But trees don't get going very fast. It takes them 10 or 20 years before they reach their full capacity to suck in the carbon. So there's a period of time where that's lower. So this is over time, we're still trying to account for these things. So my point is that this gets very complicated, but there are interrelations between the two that we need to take into effect. And I'll be talking more about that as I get into this a little bit. So let's think a little bit more about the urgency of the climate crisis. The IPCC indicates that 1.5 degree of warming could occur between 2030 and 2052. Folks, that's right around the corner. It's happening right now. And I noticed that their IPCC says 1.5, that Bloomberg quote said 2. So we're kind of getting to the point where nobody's really sure we can keep it at 1.5. They're starting to talk about 2. But it's really important to keep it at 1.5, or we start to have other problems, and we don't know what happens after that to some of these things. So we're still trying to figure out a way to keep it to 1.5 degrees by 2040. Here's an example of the longer we wait, the harder it is to get to where we want to go. If we're looking for 1.5 degrees, that slope gets steeper. We have to bring it back to zero. We have to do it within the next 20 or 30 years. The longer we wait to get down there, the harder it is. We're still emitting more. So that curve is going up. It means you have to have farther to go to get to zero. And as we said earlier, it's not enough just to get to zero. We're going to have to take carbon out of the atmosphere and find ways to do that. We have agreements under the Paris agreements. Unfortunately, the US is not involved in that at the moment. But even if we met the Paris agreements, that's not enough to meet our goal. We're going to go over that with the current agreements and the current pledges. And then we'll find out what happens. It's not a good thing to do that. So we have a real press to find all the possibilities that we possibly can to move into play and align with this climate mitigation problem. Electrical vehicles, better heating in home, building. Let's build different. And what do we do in our forests at the same time? So our sector, the forestry sector, believes now it's our time to figure out how to do that. And we at New England Forestry Foundation have spent a lot of time trying to figure that out. If we go beyond the 2 degrees or 1.5 degrees, somewhere in there, some bad things might happen that are called tipping points. And they happen at different points in time. You can look at the colors on this chart. 1 degree centigrade to 3 degrees centigrade, causes the Greenland ice sheet to begin to melt and the West Antarctic ice sheet. That's happening now. We're seeing that because we're in that temperature range. If we go too far, we hit other things. The jet stream changes and the boreal forest changes. We don't know when that gets in place what other effects it keeps magnifying. You go too far on this, then you don't have any permafrost or Arctic winter sea ice, and big things start happening on the planet. So there are tipping points that we don't want to reach. We need to do everything we can, and we need to do it right now, or we're definitely going to reach those tipping points. There's a way to do this. We can still achieve our goals. And this is a interesting graphic that shows the course we're on to a hothouse Earth if we don't do anything, but we can change our course here if we have the will and the political will to what we can call a stabilized Earth. Now, this is going to be important right in our lifetimes, important in your children's lifetime, but also important for many, many generations to come. Once the planet gets heated, it just doesn't turn around. You can't just change it and bring it back to where it was. So what happens in the next 10 to 30 years is going to have an effect on multiple generations of human beings for hundreds and maybe thousands of years. It's an exciting time to be alive. There's things that we can do, and let's turn our attention to getting them done. So we're foresters, we're a conservation organization, we take this seriously, and we spent most of our time now trying to figure out how we can address this problem. If we can't solve this problem, then most of our mission as an organization is going to be jeopardized. We love forests, we want people to recreate them, enjoy them, manage them, get productivity out of them for every generation in the future. But if climate change happens, it jeopardizes all of that. We need to solve climate change if we want to have a future here at the New England Forestry Foundation. So we're working really hard to do that. We've already conserved over 1.2 million acres of forest. That's bigger than the state of Rhode Island. A lot of that is in Maine. We're constantly showing people how to manage their forest better. Now we turn our attention to climate change to see what we can do there. We're trying to lead by example. We have now we're up to 150 community forests where we demonstrate the kind of forestry that could have an impact on climate change. All these properties are open to the public, and we hope that you enjoy it. Find one. You can go on our website and go out for a hike, watch some birds. We've conserved these forests. This is our record. We're scattered pretty much over most of New England, particularly the southern 2/3 of New England. I just signed papers today for 6,000 acres up in northern Maine. So we're also beginning to make headroads about establishing demonstration forest up in those forest types. We started this work about 6 years ago by publishing this book, which is what we considered the path to sustainability. How are the ways we can use our forests to have a sustainable lifestyle in New England? And one or two or three of those paths, signposts along the way, have to do with climate change directly. And one of them you can see right down here at the bottom, if my cursor is showing that, is building with wood. And there are other ones about mitigating climate change. But this was the one we began to focus on because it had the most potential, we thought, for solving the climate problem. This is our 3-part climate solution. These are the things that we need to do. We need to start doing them now. We have to end forest conversion. We're still developing our forest land, and that forest land is going out of forest and into houses and buildings and parking lots and Walmarts. When that happens, all the carbon is removed, no more trees are grown, there's no more potential to impact climate, and we lose. So we have to stop the rate of development in New England. We're still losing quite a bit of forest in all the states of New England. We want to turn that around. One of the good news is I just saw some statistics that over the last 30 years, the entire US actually has more forest land than it did 30 years ago. I think that's surprising to a lot of people. It's not the case here in New England, although we haven't lost that much yet, but we'll continue to drain our capacity if we allow development to continue as it is. So we're trying to solve that. The second step, change the way we're managing our forests. And that's why I went to school, is to learn how to practice a kind of forestry that was very productive and very sensitive to the ecological values in the forest. This is being practiced by the New England Forestry Foundation on our demonstration forest and by many other foresters, but actually not all of them. I heard a New Hampshire forester tell me the other day that all the trees cut in New Hampshire, only 10% of them were done under supervision of a professional forester. You know, that's not the way we need things to go. We learned our trade and our skills and our ability to keep the forest healthy and productive. And if we're not used, we can't make that happen. I believe as a forester, I can make your property twice as productive as it is if you don't use my skills for somebody that has the same skills. I mean, that's like a farmer, somebody offering them, you know, I can double your corn yield per acre, and the farmer not accepting that help and just continuing to get the same yield. And if you look back historically, when hybrid corn was first introduced, it doubled and tripled the yield of corn. But the farmers didn't plant it for 10, 20, 25 years. The agriculture partner was trying to get them to plant a type of corn that would double and triple their yield, and it was hard to do. Eventually it happened, but it was hard to do at the beginning. And it's the same problem that we have here. New England, the forest of New England, are held by 210,000 private landowners. That's where most of the forest is owned by. And we have to reach each of these people and help them introduce exemplary forestry into their forest so that they can have a better forest, a more productive forest, but also help with climate change. And they're a tough crowd to find, track down, educate, and bring the right tools to bear. But we're getting better at it all the time. But that's going to continue to be a challenge for us. It's not like going to the federal government and saying, change your practices. We have to go to 210,000 independently minded people and get them to change. But we can do it. And we have the data and the statistics and the experience to show that it works. And once we do that, we can move the products from these more productive forests into wood buildings and store more carbon in the buildings. Put the two together, you get a new climate wedge that's very significant. So let's walk through this a little bit on how this happens. We're going to start with the exemplary forestry. I'm going to give you a little bit of an introduction to forestry. As I said, the forests are owned by private individuals. Everybody owns a woodlot, different size, 10 acres, 100 acres, 1,000, 5,000. There are 210,000 smaller landowners in New England that own a lot of the land, and then there are 40 other landowners that own big, big chunks of land, up to 1 million acres of land. A lot of them are in Maine and up north. So 40 owners own about half of the land in New England, and 210,000 own the other half. But what can we do with that? We can introduce these forestry practices. This is an example of what we're doing. Most of our forests are natural. They seeded in just naturally. Farmers used to farm the land. You see stone walls running through the woods everywhere. Farmers left to go somewhere else, abandoned the land, the trees seeded in, they grew up naturally. They're being harvested or left alone or any number of things since then. But we're working with natural, biological hardwood and softwood stands. When we find these, there's a complex mixture of trees in them. Some are well adapted to the site, some aren't. Some are in very good shape and form and can grow for many years. Some aren't. They're twisted, they're rotten, they have problems. They're just never going to make a good tree that could result in a product like a saw log or some sort of timber. So if we want to grow those kind of products, what we need to do is shift the growth possibilities of the site onto the trees that can be the best producers. That's not really rocket science. It's just going in there and saying, that tree doesn't look so good, and that tree does. I'll take that tree out and let the better tree grow a little bit more. Of course, I simplified that. Foresters have a lot of knowledge and background. Which kind of tree is it? How do I think it's growing right now? What's its shape? What's its form? How long will it live? What are the soils like? Is it well adapted to these soils? How much spacing do I need to give between these two trees? How can I optimize everything that I'm doing to make this acre the most productive as possible? So they make those decisions. You can see in these 4 pictures, you start with the natural forest, you do a harvest cut. You start to remove some of the poorer trees. Looks pretty messy at the beginning, but give us a little time. You know, after a while, you see the other picture 20 years later, the forest has sort of sorted itself out a little bit. And then 20 years beyond that, you can actually get a good picture of how the early thinnings of these trees are putting the growth on the better trees. I've used this slide before. I didn't create it. It was handed down to me. But I noticed that the individual in the bottom 2 slides are it's actually standing in front of the same tree, 20 years apart. So you can see in the bottom right, those 2 larger trees up front and the person standing in front of the larger tree in the back. Those 2 trees up front are in the picture on the left. So you can see how much they've grown over those 20 years. While there's less trees on the property, there are bigger trees. And those trees can be made into products. So that's the whole key here. That's how we go through this and make the forest several times more productive if we do the right thing on the forest. So that begins the progression through the stand. It brings us up. Those trees aren't very big yet, but we're getting where we want to go. If you kind of project what we're doing into the future, you start to have forests that look like this, a little bit farther down the road. Those are those little skinny trees we started with after 40 or 60 years. And I've been around for a while, so I've got some stands of trees that I thinned a long, long time ago that I can actually see this taking place. And you stretch it out a little bit farther, and you get some really beautiful trees. It's not that we grow every tree to that size, but some of them we do if they're well adapted to do that. So that's your quick guide through how you manage a stand of trees to be more productive. So let's continue and think about how we translate that into a climate change. As we said before, forests store carbon. It's not in the atmosphere if it's in trees. If you cut all the trees and burn them, it all goes into the atmosphere. And then the trees will start to regrow, but you've got a lot of carbon in the atmosphere before the new trees take it out. So if we look at New England, this is a map of where the carbon is. You can see in western Massachusetts, heavy stocking of carbon. And as an example of the polar opposite, you look up in Maine, in sort of northwestern Maine, the blue areas up there, low carbon stocking. So what's happening here is these are different landowner types. I told you the larger landowners that own hundreds of thousands and millions of acres, they're industrial owners or investment owners, they're up in Maine. And the smaller private landowners are down here in southern New England, and they have a lot of, so there's a lot of carbon in the small landowners and not that much carbon in the large landowners. So that's an obvious difference. We have to pay attention to that and be able to help both of those landowners do the right thing for climate change. I might flip back and forth a little bit between slides. These are a couple of interesting slides here. You can see on the left slide, the left graph, harvest per acre on lands. And in southern New England, we're not harvesting very much per acre. In northern New England, we're harvesting quite a bit more. The second graph shows you the amount of wood consumption. The big red bar in Massachusetts says we're consuming a lot of wood products, but we're not harvesting many. The big blue bar in Maine says we're growing a lot of saw timber and harvesting it, but we're not consuming much. We're all New Englanders. We're all Americans. We're all on the planet Earth. How do we kind of work this out together to get the best results here? So if you go back, which I will, to this slide, so some of these landowners need to harvest a little bit more, and some of these landowners need to let their trees grow a little bit more. So when that happens, there'll be less products coming out up here, but more here, which may balance themselves out, allow us to build wood buildings. The carbon in Massachusetts may dip a bit, but the carbon in Maine will go up a lot. And I'll show you graphs on that because that's the way the forests are growing. So we need a systems approach, a regional approach to this. We can't put ourselves in silos and just think about Massachusetts or Western Mass or Northern Maine. Here's a region that I'm familiar with, and I work closely with the folks up here. We call it the Mountains of the Dawn. This is the region that goes from White Mountain National Forest in New Hampshire all the way up to Mount Katahdin. It's the area on the map previously that had low carbon. So we're working in this area trying to figure out what kind of forestry should be practiced. What do we need in terms of wildlife? Because it's not all about producing more material. It's also about doing the right thing ecologically. So we figured out across the landscape what the best kind of forestry would be for wildlife. So we believe we can protect and improve the habitat for wildlife while we increase the carbon in the forest and have a climate problem. We can do both in these areas. In order to help us do that, we've got guidelines. There's guides for biodiversity in the forest of Maine. I was one of the people that was part of the group that helped develop those guidelines 20 years ago. They still work today. They tell us what we should be doing in those forests. We need more big trees there. We need more larger blocks of land where the tree canopy is close and tight. So there's a number of things we understand that can be accomplished through the forestry while the carbon is growing and while we're producing products. This is the key for foresters. Go to forestry school, you learn these stocking guides. What this guide tells you is in any particular forest, you get the guide for that forest, and you want to harvest or thin the forest so that it stays between the green and the red line. It's above the B line, below the A line. That's where the forest will grow the best. So if it's above the red line, the A line, you need to thin a few trees out. If it's below the green line, you need to let them grow until the stocking goes up and you get more productivity. So you're trying to keep it between the green and the red line. That's a pretty simple concept. But what's happening in New England, as I showed you on the carbon chart, the landowners in Western Massachusetts are above the red line, and the landowners in Maine are below the green line. So we need to get them both between, and that's what will help. We developed these exemplary forestry standards. I don't expect you to read this. It's all listed on our website if you want to go. The thing we wanted to do, though, is we wanted to be able to do that on one page, not make it too complicated so people could understand what we're talking about. If you follow these guidelines, the amount of carbon we can protect in our forest and the amount of products we can produce are very, very significant. Just follow the guidelines. So we've done that on our forests and have proven this, and we've modeled this on what would happen if we applied it to other forests in the region. The next 3 or 4 slides are the key slides here if you want to understand forestry. This is the growth by stocking class. What this slide tells you is that the more stocking you have per acre, the tighter the trees are, the more trees you have per acre, the more you will grow per acre. So if you're in a region like Upper Maine, where your stocking is very low, you're not growing much each year per acre. That's a tragedy. That land could produce more with better forestry. So the red triangle is the average for, the red triangle is the average for Maine, but the optimum is this star up here. On the Maine public lands owned by the state of Maine, they're very close to the optimum. They're practicing really nice forestry. But overall, the stocking is too low and not very productive. If we move this average up this way, we get more per acre, which allows us to do 2 things. Have more carbon in the forest, send more to wood buildings. We can do both of those things if our productivity is higher. That's how we make this sort of magic happen. This is the chart of our lands and 1 or 2 other lands. Over 40, 50 years, we've kept track of how we're doing. And what this chart will tell you is that after a long time, we've harvested a lot of wood out of these properties, but they are more heavily stocked than when we started. So there's more carbon on these properties than when we started, but we've also harvested wood that potentially could have been used in buildings over the last 30, 40 years. This is how it works. We've proven it. We can just apply it to other properties. If you want to model this out, take our exemplary forestry standards, apply them to the current stands in Western Maine, and then grow them forward and see what happens. This is the result here. The carbon goes up dramatically. So where we started at 135 total, we're up to 181. And then over time, that's adjusted and averages out, but you can see that it winds up very, very high over a long period of time. That's how we got a big carbon sink, by handling these forests in Maine. In order to get here in Maine, we have to harvest less in those early years until the forest becomes more productive and then produces more. We can balance the reduction in harvest by harvesting a little bit more in southern New England. And that's how the system will work together. The last one here of the four important slides is a study done here in Massachusetts, where they actually modeled applying something like our exemplary forestry standards across the landscape for 50 years. And what they found is after 50 years, that's this red circle here, the amount of carbon in the forest was almost the same, a little bit less, but almost the same. But the amount of timber had doubled. The amount of timber that we had removed from the forest was double than what we're doing now, while the carbon is about the same. That's how it works. You keep the carbon in the forest, you double the amount of timber. What's the climate effect of this? Well, if you just look at the forest, you've got a little bit of a negative effect, but now you've got twice as much wood to replace steel and concrete. You get a big climate effect from not burning the fossil fuels for the steel and concrete and keeping that wood in buildings. This is how it works. That's our system. I'm going to skip over this a little bit to just save some time. But my point in the previous slide and this one here is that some people think the best thing to do with our forests is just to leave them alone and stop harvesting. The problem with that is people don't stop using wood, so the material has to come from somewhere. You remember that big red bar for Massachusetts in consumption? We could stop harvesting, but that bar is not going away. People in Massachusetts still want to use wood products. They're going to buy them from somewhere. So it really doesn't solve the climate problem if you just move the harvest somewhere else. I won't harvest my woodlot, but you'll harvest yours. Or we won't harvest in Massachusetts, but they'll continue to harvest in Maine. Or we won't harvest in New England, but they'll harvest in the Amazon. So that gets us nowhere. The climate doesn't see, remember I used that term? What does the atmosphere see? It doesn't see any difference if you just move it around. It will see a difference if you're more productive per acre by using exemplary forestry. It will see a difference if you don't build the building out of steel with all the emissions, but build it out of wood. So that's the point that we try to make with people. All right. Now, I think I'm pretty much on schedule because I've done a lot of my forestry background work, but now it's about buildings. I think this is a slide of China. I just pulled it off the web, but I've been seeing these tremendous pictures of cranes building buildings all across the landscape. It's a different world out there, I guess. But this is what's happening. Remember I said 2.3 billion more people? And a lot of those people that are going to be alive and people that are living in rural areas are moving to the cities all over the world. So this is the kind of development that we're going to have in order to provide for those folks. And boy, that must be all steel and concrete in there. And that's what's going to keep us from solving our climate problem. So what do we do about that? Well, you folks have some of the answers. I was delighted when I began to learn about engineered wood. It's been around for a couple of decades, but I hadn't heard much about it for maybe until about 8 or 9 years ago. That now we can engineer wood and we can actually build buildings, taller buildings. And these are your products You know more about them than I do, but glue lam, cross-laminated timber, nail laminated timber. Building these beautiful architectural designs, they're more flexible, they're more aesthetic, they're more pleasing to be in. I think they're wonderful. You're familiar with one of them on your own campus. So I'm not telling you anything new. You've experienced it if you've been in that building in Amherst, what that's like. These are just pictures from around the world that I've kind of pulled together. It's happening. It's increasing. And then I just had, I do this slideshow for other people. They need to see this stuff. But the architectural designs, I think, are fascinating for people to see that, what happens. My favorite, you can make bicycles out of wood. This right now is the tallest building in the world. That's going to be, that position will be taken over, I understand, by a building that's now started in Milwaukee. So you're going to hear the competition and charisma for the tallest building. Everybody likes to talk about the tallest building. I put it in my slideshow too. But it's actually the buildings that are probably between 5, 6 stories and 12 stories that are the most important. If you look at the mass of materials that go into building around the world, not that much of it goes into these taller buildings because there aren't that many of them. But there are multitudes of the 10 to 12 story buildings. And so that's where most of the mass of materials will go. And that's where most of the pollution will come from. And that's our target area. And that's well within the range of our building codes and our ability to make these buildings and make them very livable and comfortable. So we don't need to go high. It's fine when we do, and we'll get the publicity, but it's the 5, 8, 10 story buildings that are going to make the most impact on us. I found this one again. People talk about, well, that's all great. We hear what you're saying, but wood buildings are dangerous. They might burn. There have been the appropriate studies to show that they are not totally fireproof, but they're well within the range of being safe for fire. They constructed apartments out of wood. They furnished them. They lit them on fire. They videoed it. They watched what happened to them. The fires went out. The cross-laminated beams and other materials basically charred but didn't burn. They're fire safe like anything else. This is a picture of melted steel beams draped over a wooden beam. So I don't know how factual or truthful it comes from the Forest Products Lab. I think it's a very old picture, but it tells you that wood actually can last longer than steel in some cases in a fire, but certainly long enough to pass the fire codes. The codes are changing. They're allowing these buildings to be built. The latest reports that I've heard are that there are 500 engineered wood buildings now existing, about another 500 under construction or in the late design phases. We're going to have 1,000 buildings pretty soon, and that's just the start, because there's 17,000 buildings a year that this could be applied to. So we got a long way to go. We're just at the beginning. It's a really exciting phase to be at. So let's kind of summarize here at the end. What do we need to do? As I said at the beginning, first thing, everybody agrees. We need to stop conversion of forests to other uses. We need to keep our forest intact, or we can't manage them, or we can't have the carbon sequestered. The potential to mitigate climate change is enormous. This is one study, the sort of singular study that came out about 7 or 8 years ago, that showed that if we did this around the globe, just using the growth of forests, not harvesting any more, just using the growth, there's a potential to offset 31% of human emissions. That's incredible. That's a big number. And that's the chart I was talking about to the right here on the opportunities in tall wood buildings, where the height and the amount of material in them. This was an op-ed article that we, the New England Forestry Foundation and others, posted in the New York Times about how this happens. What's this system? How do you work the forest to the cities and make all this happen? We condensed this into an op-ed that got published and got some publicity for us. So this is our capsule summary of how this all works. I encourage you to take a look at that if you're interested. This is just a little bit about New England Forestry Foundation. We do a number of things here. We're talking about buildings and wood and exemplary forestry, but we're involved in, there has to be a lot of things going on in order to make this work. As I mentioned, there are 210,000 forest landowners. They need a way to protect their property from generation to generation. So we created a pooled timber income fund that could actually register, put their property into a fund with other landowners, and we could all manage them together. There's an exemplary forestry investment fund. There's a lot of money out there looking to be placed in places other than buying stocks in the stock market. Solid, low yield investments over time. And we're looking at setting up a fund for that investment money that could buy land that would be managed according to exemplary forestry standards, and the materials could be used in building with wood. We've developed standards for northern New England. We're now almost done with our southern New England standards. We're working on wildlife. How do you reach these 210,000 landowners? Have a pilot program that's 4 years old that's improving our ability to reach these people. That's communications. And of course, I've talked about Build It with Wood. That's what we do. Our Forest to Cities program is the last thing I'll mention, and I'm hoping that you can be involved with us on that. We're asking everybody interested in this topic, the ability to build these buildings out of good forestry, to sign the pledge, to sign on to the Forest to Cities Climate Challenge. And this is the pledge. It doesn't commit you to that much. It just says, this is a good idea. Count me in. I want to do it. We ought to be working on how to make this happen, practicing better forestry, and getting the buildings built. So it's a win for the economy. It's a win, for the forest. It's a win-win-win. There's 4 wins here, and I want to do it. So the last thing I'd ask you is go to our website, sign the pledge. We're a little over 90 individuals and organizations that have signed on to it. Some of the major ones, we started with organizations that we really need on our side, but we're trying to expand to everybody. It would be wonderful if this class could go on this site and take the pledge and sign up for it. And then my staff will wonder what I was doing late afternoon and whether I accomplished anything. So I could point to that as a real achievement. So please go to our foresttocities.org website and take our pledge. That's pretty close to the hour. I didn't know I could talk that long, but I certainly could. So I think I'll end now and move us into the second phase, which is questions.
Sounds great. Thanks, Bob. Can you hear me well?
I can. Yeah.
Perfect. So we do have a lot of questions coming through the chat, and I just wanted to encourage everybody again to post them in the chat and send them directly to me so that I can forward them right here, right now. So one question that had to do with your comment about reducing forestry in northern Maine, and the question was basically how those landowners can be incentivized to change the forestry practices to cut less, basically, and the owners in mass to cut more. What kind of policy outreach options do you see?
Really great question. That's what we're working on. So you're exactly right. We're suggesting to these large landowners that have made a significant investment in hundreds of thousands of acres of land that they harvest a little bit less for a while. That means less money coming in. And they have an obligation to produce a return on their money. A lot of these are investment funds that have taken money from a pension fund or other investors, and they are pledged that they will return a certain percentage each year. They stop harvesting, they can't do that. So here's what we think should be done. If they stop harvesting a little bit, they'll be storing more carbon. That's a climate benefit. Well, let's pay them to do that. Solar is subsidized, electric cars are subsidized. So what we've been saying, particularly here in Massachusetts, to the policymakers is, if you want to meet your climate goals, there's a way to do that, and probably a very efficient, effective, and economical way. Pay those main landowners a little bit, and they'll store a lot of carbon for you. All you need to do, because they'll still be able to do some harvesting, you need to make up the difference between the lower harvesting and what they would have done for a while. And that, we believe, would be a real, very reasonable investment. That makes a lot of sense. The difficulty is connecting the Massachusetts decision makers with the main landowners. Hey, these are different states. They don't necessarily talk across state lines and do things like that. Massachusetts is thinking about Western Massachusetts, which is good, but we need to also make the connection between Maine and Massachusetts. You know, Maine used to be a part of Massachusetts back 150 years ago, so we need to kind of bring the people connected. So we're doing that. We are having those discussions with the policymakers, and we're getting a little bit closer here. That's the challenge, but we think that that can work and work really well. Part of that connection is we need to keep the harvest up close to what it is because there's a demand for the material. And that's where that triad, you know, consumers in Boston, landowners in Western Massachusetts that aren't harvesting, and landowners in Maine that are harvesting too much, we need to bring them all together. And together we can solve this problem. Harvest a little more in Western Mass, harvest a little bit less in Maine, satisfy the consumer in Boston. You got it. And while we're doing that, we're mitigating climate change. That's where the money should come from.
So could I just follow up on that? So are there any states, not necessarily in the Northeast, that have actually got a carbon subsidization program in place?
Well, you know, there are carbon markets that are originated in California and are being expanded. So through the California system, California will buy the rights to your carbon. And on my organization, on a property in New Hampshire that was dedicated to no harvest, we sold California our carbon rights. So we got paid a lot of money to not cut the trees we wouldn't have cut anyway for this particular property. But those carbon markets are available. We got in at the beginning and it was an exceptional case. Right now it's very difficult to get into that market because they're changing the rules. They're making it harder. They're not paying as much as they used to. So not that many landowners are actually getting into that carbon market, but it's available to them. What we're saying is let's broaden that. Let's make it a lot easier. Let's actually make it work because we have to make it work now. Most of the landowners in New England aren't participating. Well, we got to find a better way, an easier way for them to participate.
All right. Let me throw in another question. It's actually a set of two questions. I'm combining those. One was about the practice of thinning and basically removing smaller trees from the forest. And then the other question was, is there an opportunity for using those in products like CLT, glulam, etc.?
Yes, and another good question. You saw my slides. In order to do those initial thinnings, you're taking out trees that are very small, and that immediately throws the growth on the better trees, and we wait, and everything works out over time. But how do you get those smaller trees out in the early years? That's one of the problems. Either you can pay to have that done, but landowners don't want to do that. They don't want to pay $8,000 today for a return in 20 years. So it's best if those products have markets. So what can small trees be used for? When I say small, I mean 5, 6, 7, 8 inches. Those trees can be used for firewood, and they can be used for biomass to offset gasoline or gas. So those products right now are the ones that are available. I'm talking in southern New England mostly. They aren't great markets. When I was a forester, I wanted to do that kind of thinning. It was very difficult to find the market or somebody to take the trees out. It wasn't impossible, but it was hard. In some cases, it was impossible. So there are many stands that aren't being thinned because we don't have the market for that. There are possibilities, right? It would be nice if we had a better biomass market that was heating schools and municipal buildings across the state. There's a program, it's expanding. I wish it would expand more because it would allow more of these thinnings to take place. There's some very interesting products like wood insulation. There's a new plant in Maine that's going to be up and running at the beginning of next year that will use these smaller trees to produce a wood fiber insulation that is used to insulate homes, to take the place of the orange fiberglass that we see every place that are in homes. That would be a great use of that and can be expanded greatly. One of our hopes is that these smaller trees can be used in CLT. Now, Peggy can tell you more about that. Everybody at the beginning wants a bigger board, a bigger tree to cut it out of because that's what they're working with now. But I think over time, as the market grows, we could see different tree species and smaller trees used in engineered wood products. It's certainly possible, but if you had your choice, you'd probably take a bigger board from another kind of tree. But eventually that also lends a possibility to enter into that market. But that is one of the constraints that we have. To growing our forest better, we need better markets for small materials.
Can I just jump in and follow up with that? If you look at the glulam columns in the design building closely, you'll see that they're actually made out of 1x2s all glued together, these massive columns taking so much load. The species is black spruce from northern Quebec, so it's a very dense, high-quality wood, so it works well. We don't actually have that here in Western Massachusetts. As Bob was mentioning, we have a very complex mix of hardwoods and softwoods. So it's possible, but research needs to be done to figure out first whether our species could be put into large-scale structures or maybe mid-scale, like what Bob was saying. The 6 to 12 story market would be ideal. But we're working on it. Put my plug in for my research in the design building lab.
Exactly. Actually, a follow-up question came through a second ago about thinnings and basically the benefit of what's left in a process like that to the forest. So basically, what portion of those thinnings need to be left on the forest floor to return those nutrients to the trees?
Another excellent question that I was part of addressing about 10 years ago when I was with the Forest Stewards Guild, which was mentioned before I worked for the New England Forestry Foundation. I was one of the founders of the Forest Stewards Guild. And at that time, there was a lot of discussion, particularly in Massachusetts, about biomass energy plants and whether we would build them here and whether the forest would supply them. And one of the questions everybody asked is, we want the forest to be whole, ecologically whole. And if you keep taking trees out of there, aren't you going to deplete the soils? Aren't the trees going to start growing more slowly? Are you damaging the long-term productivity of the site? So we did an extensive and intensive survey of all the literature and studies and research. And our conclusion was there doesn't necessarily need to be a problem here. We can harvest trees out of the forest, but it would be a really good idea, so we set a standard, that 1/3 of all the tops and the smaller branches in the trees should be left and not taken out. So you don't want to go in, remove everything, every part of the tree. You leave some of it behind. And 1/3 is a good guide. On some properties, you don't want to do any harvesting at all. On some properties, you would leave all the tops. And some would be so productive of soils, and you would enter them so infrequently that it really wouldn't matter. You wouldn't impact the soils if you took all the tops of the trees. But the rule of thumb is 1/3. And I find that on almost every job that I've seen in the woods, that's pretty much what they leave. They just can't take everything. Things are always falling down, small branches and trees, and you usually get about 1/3 left anyway. So it's not that big of a change. We think our soils are in good shape if we do that.
Let me switch to a different current topic, of course, there were some questions coming through about the forest fires in the West, and the question, of course, how much of that, discussion, how much it relates to climate change, how much it relates and can be affected by forest management, and then, of course, a question came through whether that future or that scenario could be in our future in New England.
Yeah. I'll work backwards on that a little bit, because I like the question about forest management out west. People refer to our forest in New England as, I've heard the term asbestos forest. They tend not to burn. We get enough moisture, they stay moist most of the year, and we don't have really big problems. Every once in a while, something happens. There's fires in Maine, I think in the 60s, and if you've ever been to Mount Desert Island, Bar Harbor, there's big forest fires in the 40s that totally changed the island. I remember as a kid driving down through New Jersey and seeing the pine barrens burning and the smoke blowing across the New Jersey Turnpike. And, there are potential problems, particularly in the pine barrens. If you ever want to do any research on that, they're ready to go up. But pretty much in New England, we're just fortunate. We're not that worried about that. But you can see the dry spell we're having now. We're having a few more fires, and it gets more concerning. Climate change could impact that, our security on the forest fire issue, particularly because the prediction is that we won't get less rainfall, but it may come more intensely at different points in the year, which means there may be longer periods where we're not getting anything. So you look over the whole average, you're okay. But you might come into a long period where the forest dries out and gets to a condition where it could burn. So we could have problems, that's the answer. But right now, we think we're okay. The other question is sort of a politically loaded question, because I think you all heard our president talk about the fires out there and say it was a management problem. And, as a lot of the things we're hearing, that's very simplistic take on a very, very complex issue. Forest management is one of the things we need to do to address the fire situation out there, but it's all built on top of climate change. And that's what everybody that knows is saying. If you dry the forest out, the temperatures there were extreme. You saw some of the data. Maybe the hottest day on the planet occurred over the summer. There were long days of very high temperatures, abnormal, that created winds that were blowing in from the east across the mountains the other way, very strong winds. These are all climate-related problems that are exacerbated by the underlying level of climate change. It all gets mixed up in any particular event could happen in a weather situation. Yes, we know that, but the number of these extreme events that are happening now, you look at the charts, you know that it's related to climate change. It just is. You also heard forest management. Mistakes were made for many years on the federal forests, mostly, that they did not allow the fires to burn. Smokey the Bear. They began to put everything out in forests that naturally burn periodically. And that meant the forest changed its natural characteristics. There's a lot more trees, a lot more deadwood, and the fire hazard went up in these forests where it would have been ameliorated if they had been allowed to burn. It's too late to turn back the clock. That's what happened. Now we've got these forests that are loaded with fuel. One way to address those is to go in and thin them out. But boy, it is hard work. And the number of acres that you can accomplish, it sounds from the president that you just go in and do some raking. It's not like that. The Forest Stewards Guild, who's based in Santa Fe, has a whole program and young people out there doing those kind of activities. But the number of acres are just minuscule that we can cover with that kind of physical labor. The other way is to actually let the forest burn, set fires and burn them ahead of time. That's all being tried. We got a big problem and we don't have the ability to address all of it at any one time.
Can I just jump in with one additional? You mentioned how climate change is causing other issues in the forest, and part of that is it's exacerbating infestations. So we do have several species that will remain standing for a few years after bugs kill it, but ultimately it will fall over and rot and release the carbon back in the atmosphere and potentially become fuel for forest fires. So it is a much bigger issue that we need to address here on the East Coast, I think, proactively in the years to come.
Let me just ask one more question about sustainable forestry. What do you see as the main driving force for increasing sustainable forestry? And actually, a second question would also be how you define sustainable forestry, especially with the certification systems out there, FSC, SFI. What should we promote? What should we use here?
So sustainable forestry means treating the forest in a way that doesn't hinder its ability to be used by future generations. You know? So if you, as I alluded to before, if you're harvesting the forest so heavily that you damage your soils, 50 years from now, people that come after us won't be able to grow trees like they're growing now. So you can't do that. So you need to treat the forest in a way that it will be available to all future generations. We're actually at NEFF finishing a paper called Redefining Sustainable Forestry. So if you look back at forestry over about 150 years or so, that in Western cultures it's been used as a profession and practice, there have been periodic changes to what we thought was sustainable forestry, to the point where we began to worry about different animals, biodiversity, fungi, things like that. You know, there's been a change over time. So now it's time for another change. That's what we're saying in this paper we're going to release. The difference now is you can look at sustainable forestry and say, I know you're harvesting trees and the soils are going to be okay and the trees will grow back and the carbon will come back into the forest, but that'll happen 80 years from now. That's sustainable forestry. We look out over 50, 80, 100 years. I agree, that's sustainable forestry. The problem now is that if you're practicing a kind of sustainable forestry that removes carbon and lowers carbon levels in the next 10 or 20 years, that's a problem. That's a problem for all of us. It's a problem for climate change and a problem for the long-term health of the forest. As Peggy said, if we let climate change run away, we'll get another or 2 or 3 more pests in here that will damage our forest. We all need to solve the climate problem now, including foresters practicing sustainable forestry. So the new test should be you are maintaining your carbon stocks pretty close to where they are, at least during this 10 to 30 year period. Right? So show us that you're doing that. That's the new level, what we call exemplary forestry, sustainable plus. So the certification services that certify sustainable forestry are beginning to look at this to maybe do an addition to what they're talking about. We're the ones that are nudging them. You know, you need to think about this because we're seeing properties in Maine that you have certified where all the carbon's leaving the property. And it's going to leave in the next 10 or 20 years. You know, as a forester, I know that it's sustainable. It'll still be there in 50 or 80 years, but we can't do that during climate change. So let's change our definition of sustainable forestry that fits this climate era that we're in.
No, I think that's a perfect statement to end up our lecture today. So in closing, I'd really like to thank Mr. Perschel for a great presentation and alert him to the arrival in his mail of the much coveted BCT water bottle.
Whoa, yeah.
As a token of our thanks. And the rest of you who are here,